Hey guys, today I will show you how to solve differential equations by separating variables. Say you have been given something like this: dy dx equals 4x squared plus 1 over 3y. Sometimes it's called separable differential equations, and this type of differential equations can be solved by rearranging variables to get y on the left side and x on the right side, or sides basically could be swapped. Now, look at the right side. So you have a kind of a mixture of concoction x and y terms. So the idea is a good rule of thumb. So we want to break it down, we want to split it up, or we want to rearrange it somehow in order to get, so normally y terms on the left side, on the one side of your equation again. So I'm going to repeat myself, and x terms on the right side of your equation. So let's do it. For this one, the first step, what I'm going to do, I'm going to multiply both sides of your equation by 3y in order to move it to the left side. So, and don't forget, if you do something to one side of your equation, you have to do to other side. So you don't want to change the overall value of your equation. So again, I'm going to multiply both sides of my equation by 3y. And what that does is just clear off this 3y from the right side. So in other words, I moved this 3y term to the left side. Now at this point, I'm going to move this dx differential to the right side by multiplying dx to both sides of your equation. So I'm going to multiply by dx. And again, what you do to one side, you have to do to other side of your equation. So you would be left, so at this point, dx goes away, disappeared. So basically we clear it off at this point on the left side. And on the left side, you would be left with 3y dy. You bring down this equality sign. As I mentioned before, 3y term goes away. So bring down this 4x squared plus 1. And you have this dx. Now we separated variables. As you see, you have y term on the left side and x term on the other side, on the right side of your equation. And at this point, we need to integrate as we normally solve the differential equation. So we take the indefinite integral, so we integrate. So the left side would be integrated with respect to y, and the right side will be integrated with respect to x. So you have 3y. So recall the basic integration skills at this point. So you want to keep this constant 3. And since you are given this term y, so basically it's implied, it's understood the power of 1. And all you do, you want to raise this power by 1, so it becomes 2. And you want to divide it by this new power, which is 2. You want to bring down this equality sign. And you're going to integrate these basically two chunks because you have this kind of algebraic expression. So your function consists of 4x squared and 1. So you integrate piece one by one. So again, you want to keep this 4, and this power 2 becomes the third power. So 2 plus 1 gives you 3. You divide it by this 3 new power. And all you need to do with this one, you need to tack on, you need to add x. So it becomes plus x. And at this point, you have to add this arbitrary constant of integration c, since we're going to get the general solution to your differential equation. And it's, generally speaking, it's a bunch of functions, a family of functions. They differ by this constant c. Now, let's clean it up a little bit. Always keep in mind that you want to somehow get your y explicitly written in terms of x, if it's possible. This is my disclaimer, because sometimes it's not possible, like here, and you will end up getting implicit form of your equation, implicit form of your functions. So, but anyway, try to kind of get it into nice neat form and try to kind of clean this house, so we don't want to leave the house like this. So at this point I will get the common denominator. I will multiply both sides of your equation by 6, since 6 is gonna be the least common denominator to both sides. So you have 2 and 3, and we want to get rid of get rid of these fractions that comes up at this point. So I'm going to multiply both sides of my equation by 6. Again, 6 is the least common denominator to both of these sides. So 2 goes into 6 3 times. And since 3 times 3 gives you 9, so you are left with 9y squared equals 6 gets multiplied by 3, and again 3 goes into 6 twice, and you need to multiply this 4 by this 2, so you end up getting 8x cubed. Don't forget this x needs to multiply by this 6 as well, so it becomes plus 6x. And now attention, since you have an arbitrary constant of integration c, and if you multiply c by any number, it's still this arbitrary constant of integration. So if I rename this c, let's call it c1, let's put it c2. So basically c2 equals c1 plus c1 times, 6, because basically it wouldn't matter what I'm going to add at the end. So it could be 6, c1 or whatever. Now, since you have 9y squared, so I'm going to isolate my y squared. So I'm going to get y squared alone. And the way you would do, you want to just divide both sides of your equation by 9 in order to get rid of this 9 in front of y squared. So you divide both sides by 9. And you would be left getting something like, so y 9 and 9 goes away, disappeared. So you are left getting y squared equals, so you just divide throughout by 9. So 8 over 9 x cubed plus 6 over 9. So these two numbers basically they share the common factor, which is 3. 3 goes into 6 twice, and 3 goes into 9 3 times. And don't forget this x plus c. And again at this point, c2 divided by 9, you would be left again with a constant, and let's call it just c. Alright, it seems to be your final answer. It seems to be your general solution to this differential equation. And again, I'm going to repeat myself. We end up getting y squared, so we cannot write y explicitly in terms of x. So this is kind of an implicit form of your final solution because it happens to be just y squared. It's perfectly fine for this type of problems, but at this point we try kind of get it into the neat and compact form possible. So that's gonna be your general solution to this differential equation. Alright, hopefully you are getting a grasp of it. By the way, I do have an introduction to separable differential equations. It's another video and the link would be down below in the description box. And if you are up to this, you could definitely go or jump onto this and check it out later. Alright, huge thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit this like button, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you'll not miss out my new